Okay, we continue with the same type of problem, and we are looking at this question here. So we got, now I've got the right notation here. Now I've got a bracket here. ABC is a 3-digit number. Now, given that this AAA, so that means the number with all the digits equal to A, and another number, all the digits equal to B, and so on, is equal to this. What is A plus B plus C? Okay, this looks like quite a difficult problem because you've got 3 unknowns, and there's a question that is asked here. The question is, what is the sum of the 3 digits that you have? All right, now when you've got a number like this, AAA, so take for example, if you make A is equal to say 7, so you're looking at 777. Now you can see clearly that this is 7 times 111. Right? If I had 555, this is 5 times 111. Right? So these numbers like this can be factorized easily. 111 is always a factor of this. So that quantity is A times 111, and you can see on the left-hand side, that is what I've got. I'm looking at that equation. Now here, this digit here is in the 1000th place. So this is 1000 B. Right? And this digit here is in the 100th place. So it's 100A. And this digit is in the 10th place, 10th unit. So it's 10A plus C. So I have got an equation like this. And if you look at this equation, when you take out 111 as a common factor here, you'll get this. Okay, now this, once you come to this, now this is where ingenuity comes in. And you ask yourself, how am I going to calculate A plus B plus C when you got this kind of a thing? Now, so the trick is, why don't you take the number 999B, because that's also a multiple of 111. So rewrite this as 999B plus B. So, and here, this is very close to 111 also. So why don't you make this 111A minus A? 110A is certainly that, plus C. So you're rewriting this cleverly by trying to get an 111 into this, right? This is 111 times 9, and this is 111 times A. So now you can take these numbers to the other side, and you'll see 111 goes into this as well. So you get 111 into A plus B plus C. That's on the left-hand side. Now, when you take that to the other side, this is 111 times 9B, and this is 111 times A. When you take it to the other side, it becomes minus 111 times A, and 111, I've taken it out as a common factor one time, and what's left? So this has gone to the other side, that's gone to the other side, and what are you left with? You got B plus C minus A. All right. Now you got, these are all digits, all one-digit number. You know, these numbers are numbers which are, you know, between 0 and 9. So how can that be a multiple of 111? This is 111 times something is equal to this. It's impossible. The only way you can have this is that, hence, B plus C minus A equals 0. See, this has to be 0 because it's a one-digit number. It can never be all the other. On this side here, you got a number which is at least 3 digits long because you're multiplying by 111. But it can be 0, in which case this part here is also 0. And you got A minus A is 0, and you got B plus, yeah, okay. Now from here, you can say that A is equal to B plus C, right? So this is 0, and it means that this is also equal to 0. But A is equal to B plus C. So you have A plus B plus C minus 9b minus a is equal to 0, because 111 times that quantity is 0 now. So that quantity has to be 0, right? And we had that a is equal to b plus c. So we can put an a there. And these a's cancel. And you have a minus 9b is equal to 0. So a is equal to 9b, right? Now remember, these are digits, right? How can this be? The only way for these for this to be possible, if b is equal to 2, then a will be 18, and that's not a digit. The digits are from 1 to 9, or from 0 to 9. So the only way this can be possible, and b is not 0, because this is a 3-digit number, right? Okay. Maybe a could be 0, but if a is 0, then b will also have to be 0. And then you have a this is not a 3-digit number. They are saying these are 3-digit numbers. All right, so the only way you can have is b is equal to 1, a is equal to 9. And the moment you got that, remember, a is equal to b plus c. So a is 9, b is 1. So you can substitute that into that, and you get c is equal to 8. So you've got a is equal to 9, b is equal to 1, c is equal to 8. And the question is, what is a plus b plus c? You add these numbers, the answer is 18. A very nice problem. Very nice problem where you logically, you can deduce the answers. Okay, please go over it if you didn't understand it, and I'm sure you will enjoy it once you understand it. You see how beautiful mathematics is. The next problem is very similar to the ones that we've been doing so far. It says that a is a 4-digit number, and b is the 4-digit number that is obtained by writing a backwards. So we have an example there. Like if we have a is 4367, then b, if you write it backwards, is 7634. Right. Now suppose you know that a and b are such that a is 4 times b. It means the original number is 4 times the number that you write backwards. And the question is, what are the numbers? Solve for them. All right. So as before now, we will say a is the 4-digit number, and we'll call the digits a, b, c, d. As before, it's got 4 digits. And its actual value is 1000A plus 100B plus 10C plus D. So if A is that, then B would be the same thing written backwards, DCBA, and A equals 4 times B means A is equal to 4 times DCBA, as you see here. All right. Now, without expanding, we can ask ourselves, you've got a 4-digit number and you're multiplying this 4-digit number by 4. So what are the possible values for A? You can't have D greater than 3, greater or equal to 3, because otherwise you'll have 4 times that will be at least 12,000, which is a 5-digit number. So the values for D can only be 1 or 2. All right, so as we can see here. But here's something very interesting, because 4 times this is that, so therefore this number here must be even, because it's equal to a multiple of 4, which is also a multiple of 2, so it must be even, which means D must be even. So D, if it's even, it can't be 1, right? So D is equal to 2. All right. Now, going back to the same thing, and you put D equals 2 here now, and you got 4 times something ends in 2. So the only way that is possible is that if the last digit of this number here, 4 times what, ends in 2. There are only two possibilities. 4 times 3, which is 12, which ends in 2, and 4 times 8. So therefore, A is either 3 or 8. There it is. Right. But now, A is the first digit of this number here, which is 4 times something. Right. So it can't be 3. This can't be, it can't be 3,000. 4 times a 4-digit number can never be, be around 3,000. So this has to be, A will have to be 8. Can't be 3. So now you got D equals 2 and you got A is equal to 8, right? And then we can write down our equation star, right? A is 2. A is 8, sorry, A is 8. So this number here is 8,000 plus 100B plus 10C, and D we said was 2. These two numbers, A and D, were 2. And this is equal to 4 times. Now you're starting with 2,000, with 100C plus 10B, and here you got D is equal to, A is equal to 8. So you got an equation involving only B and C now, because we've got A and D. Okay, so when you simplify this, eventually you get 2B is equal to 1 plus 13C. Now remember, B is a digit, and so is C. And so you will have to have that C is equal to 2B. This is even, and this number is odd, so this thing has to be odd. So C could be 1, in which case you got 1 plus 13 is 14, and B is 7. That's what I've got here. And then the other value for the next value for C is 3. But that gives you 13 times 3 is 39, plus 1 is 40. And 2B equals 40 means B is equal to 20. Remember, B is a digit, so B can't be 20. So this is the only possibility. Anything larger will give you, you wouldn't get a single digit here. All right. So you got A, B, C, D. And so we have all the 4 digits. And you can check that 4 times DCBA, which is 4 times, and you substitute, you get 2178, and you'll see it's precisely equal to this, which is the reverse 8712. Okay, so that takes care of that problem. The next problem involves 3 equations with 3 unknowns: x plus y equals a, y plus z is equal to b, z plus x equals c, and we've written those 3 equations down. Now there's a standard way of solving these problems. Here the problem is to find x, so you need to find x. So the way to do that is to eliminate one of the other unknowns in the usual way. So we choose to eliminate y from, for instance, from these 2 equations. You can subtract them, and y goes away, and you have this equation, x minus z equals a minus b. And the other, now y is not there anymore, and you have 2 equations with 2 unknowns. The other equation is equation 3, that's x plus z equals c, and you can eliminate z because you're trying to find x. And the way to do that is to simply add, and you calculate x to be this. There is another way of doing this, and that is where you sort of exploit the symmetry of these equations. What you do is you give a name to the sum of all the 3 unknowns, x plus y plus z. And the moment you do that, then this thing here becomes the sum minus z, s minus z. And this becomes the sum minus x, and this is the sum minus y. And there you have these 3 equations. S is the sum. And then if you add on both sides, you'll get 3s, and then you have minus x plus y plus z, and that is s itself. So here you have 3s minus s equals a plus b plus c. And that's 2s equal to a plus b plus c over 2. And you're asked to find x. So x is equal to, from the second equation here, is equal to s minus b. From here, if you substitute for s and simplify, you'll get the same thing. Okay, this seems to be a long-minded way of doing it, but it serves a very useful purpose in other kinds of problems which may not be as easy as this. You have a similar problem. Instead of having x plus y equals a, y plus z, you can say the product xy equals a, yz equals b, zx equals c. And just as we gave a name to the sum of the three in this problem, you can give a name to the product of the three, call it p, right? And then the moment you do that, then this part here becomes p, the product of all three divided by z. So this part here becomes p over z. So p over z equals a, and so on. You get these three equations. And now here we added all these three to get this. Here you multiply all the three, and you get p cubed over x times to y times z equal to a times b times c. And x, y, z is p. So you can replace this by p, and you have p squared equal to abc, and that tells you what p is. The moment you got p in terms of a, b, and c, then you can calculate any one of these other things. Right. Now here is a word problem. Oh. This problem reads the following. Steve was sorting 1,000 eggs into sizes. He was paid 20 cents for each egg that he sorted. For each egg that he broke while sorting, he did not get paid, but instead had to pay his employer 1 rand. So, in other words, each time he succeeds in sorting an egg, he gets 20 cents for it. But if he breaks an egg, he has to pay back 1 rand. You know, it says that Steve was paid 176 rand. So he knows what he got altogether. So how many eggs did he break? All right, so at the starting point, we don't know how many eggs he broke. So let's give a name to that. Okay. So if he broke X eggs, right, that means he did not break, altogether there were 1,000 eggs. He did not break 1,000 minus X. So these were sorted out nicely. And for each of these 1,000 X, 1,000 minus X eggs, he got paid 20 cents, which is 1/5 of a rand. So his income was 1/5 of 1,000 X in rands. Yeah? But he broke X eggs, so he had to give back X rands. Right? That's a loss. And therefore, his total income, net income, would be whatever he gained minus whatever he lost. And that's what you get here. And we know that the net income was 176 rands. And then you have an equation, a simple equation in X, and you can go ahead and try to solve this equation. And I think you get X equals 24, I think. Not sure. you can work out this equation. Okay. Let's get on to the next problem. In this problem, it is said that this is a magic square, which means that if you add all the three numbers in each row, you'll get a certain answer. And you get the same answer when you add any row or any column. That makes 6 different ways, 3 rows and 3 columns, and also along the diagonal. So the 8 ways in which you get the same answer. And they say that answer is K. So when you add all these 3 up, right, for instance, you're going to get K. So what does that mean? If we call this middle number X, I'd like to call this middle number X because it belongs to all the diagonals and quite a few. This middle row, and this middle column. Okay, so if you call that X, then the sum of these is 33 plus X plus 31. That's X plus 64. That's equal to K, right? Which amounts to the same thing. X is equal to K minus 64. Right? Now, what's important is that the other two numbers add up to 64. So then you'll have the same kind of thing. When you add these numbers, for instance, if you add these two numbers, you're going to get 64. And if you add, for instance, if you add those two numbers, you're going to get 64 again, right? Because the 3 numbers together with X gives you K. And then finally, if you add these two, you're going to get 64. So if you add up all the whole 9 numbers, you see you got 3 pairs of 64. Well, together with this pair, it's 4 pairs. That makes the 8 numbers. So you got 4 times 64. If you add, this gives you the sum of 8 numbers because you got 4 pairs. And the 9th number is X, the middle one. Right? So that gives you the sum of all the 9 numbers. And that is equal to, there's a K here, there's a K here, there's a K here. So that's equal to 3K. So you got 2 equations, X equals K minus 64. And you got this equation, 2 equations and 2 unknowns. And when you solve, you get K equal to 96. All right? The next problem is quite similar to something we did earlier on. The sums of 3 out of 4 numbers, omitting each of the numbers in turn, are these 4 numbers. Right? So it is, if you omit each of the numbers in turn, so if you let the numbers be A, B, C, and D, then you are saying that, for instance, if you omit A, you'll get B plus C plus D, right? That B plus C plus D is 20, right? Okay, which is the same. If you let S be the sum of the whole 4, then B plus C plus D is really S minus A, because A is A plus B plus C plus D. So S minus A is equal to 20, and like that, you can get 4 equations, right? And as we saw before, to solve this, there's a symmetry around it, so you can actually add on both sides, and you get 4S here. And when you add, there's a minus, A plus B plus C plus D equals S, and you add up all these, and then you have 3S on the side. And here, when you add these, you get 93, and and 3s is equal to 23, and s is equal to 31. And that is the sum of the whole four numbers. That was the question. So that gives you the answer to this problem quite easily. If we use that method that I told you earlier on, you see it becomes very powerful here. The next problem is a new kind of a problem. We haven't seen this kind of problem before. Let's read it. In a group of 50 girls, each girl wears either a red or a yellow shirt. Okay, each of these girls wears a shirt, and the shirt is one of two colors. It's either red or yellow. And the pants that she wears is either black or gray. All right. Now, if 14 girls wear a red shirt with black pants, 31 girls wear yellow shirts, 18 girls wear gray pants, how many girls wear a yellow shirt with gray pants? It's quite a mouthful. But there's a very nice strategy to solve a problem like this. What you do is you say, okay, now you got 50 girls all together, and each girl wears either a red or a yellow shirt. So let's put the shirts along the horizontal, red or a yellow, and I got shirts here. And down this way, you work out the pants. It's either a black pants or a gray pants. Right. So, like for instance, here it will be a girl who wears black pants and a red shirt. Here it's yellow shirt and black pants. So it's like coordinates, right? Okay, the gray is for the pants, and the Y is for the shirts. Okay, so and we can put out the number of people in each of these blocks here. And that is what you're going to do. You translate this information in a group of 50 girls. So in other words, you've got 50 girls altogether. So if you add up these four numbers, you're going to get 50. 14 girls wear a red shirt and black pants. So where's the red shirt and black pants? This is a red shirt and black pants here. So there are 14 in this block. So that takes care of the first one. 31 girls wear yellow shirts. So yellow shirts altogether, right, they could wear yellow shirts and black pants or yellow shirts and green pants, but in either gray pants. But altogether, you've got 31 girls with yellow shirts. So I'm putting down the totals here. It's 31. And when you add the total number of yellow shirts is 31. Okay. And then in the same way, 18 girls wear gray pants. There's gray, and they can wear gray pants and red shirt, gray pants and yellow shirt. But altogether, you've got 18. Okay, so how are you going to fill the so these three numbers have been filled in. But now remember that when you add these two, you're getting the sum of the whole four, because 31 is the sum of these two, and this number here is the sum of those two. So when you add these two, you're getting the sum of the whole four, and that is 50, because the 50 girls are split into four different groupings here. So this has to be 19 for these to add to 50. In the same way, this has to be 32 for these two to add up to 50. Then after that, you can fill it in easily, because when you add these two, you get 32. This has to be 18, and this has to be 13. And this is exactly what they asked. How many girls wear a yellow shirt and gray pants, yellow shirt and gray pants? And that's the answer then. So the answer here is 13. Well, that brings us to the end of all the problems that I wanted to discuss. And if I went quite fast, I know that I did, I want to apologize for that. The reason is I wanted to cover as many types of examples as possible so that you have a good idea how to solve problems if you are given a particular type of a problem. All right, so you will have the recording, and you can always go over and pause it if there is some issue that you don't understand. So thank you very much for listening, and I hope you enjoy the rest of the day or the evening, whatever the case may be.